Hello, I'm Kevin Bonham, and this is the video 3 in JuliaHub for Data Analysis series of tutorials. In the last video, we showed how you can run your R code in a Quarto Markdown file in the Julia IDE on JuliaHub. And in this video, we're going to start to move that R code into the Julia programming language itself. So instead of running an R executable in the R console, we're actually going to run our R code in the Julia REPL. So let's get to it. So here again, we've got our JuliaHub homepage. We've got our longitudinal analysis projects. If you recall in the last video, in addition to our Markdown file and our dummy samples, we also created some files that define our compute environment with all the package and package versions, project and manifest for the Julia packages that we've installed, currently just conda pkg, and then also the conda pkg package that has all of our R running packages included there. There's also hidden files that contain some environmental stuff that sort of set up our environment in a reproducible way, which is all great. But regardless, now we're going to launch. If you recall, last time we changed the default app to be Julia IDE. If you've still got our Studio here, make sure that you select Julia IDE to launch. But if you've changed the default, you can just go ahead and hit launch directly. It'll launch Julia IDE. We can connect. And when this pulls up, we're going to be in our same Julia IDE environment. And as I said in the last video, because we have that Julia project.toml file, it's going to already have activated the Julia environment. So we start installing other Julia packages. They're going to be installed into the correct environment. All right, so there we are. Once we've loaded up, we've got all our files here. The Julia REPL will start on its own. And just to show you where we're at, again, to enter the PKG REPL, the package REPL, we use the square closed bracket. So this symbol here, we just type that and it changes our prompt. We've got our longitudinal analysis here, which is the name. If you didn't put the name in yours, it's just going to be the name of the folder, which is code. And here we can type status or just st to show what our package looks like. So here we've just installed a single package, conda pkg. You can also say conda status if you want to see, we have to be using conda package in order to load that package version. Close square bracket, conda status. And that's going to look and see the R packages that we've installed. R base contains R itself, and then the other packages that we've installed to use in R. And so, and I should have mentioned, to get back to the Julia prompt, you just hit backspace if you're in the package prompt. But we're going to go back to the package prompt, and we're going to install one additional package here that's going to get us going in using our R code in Julia, and that's a package that's called RCall. We need to add it. Add RCall. So when we add this package, again, it's going to query the Julia general repository. It's going to pull down the R package and install it. When it first tries to install, it's going to look for some sort of default locations for R if we try to use RCall, and it's probably not going to find them, but we can fix that. So here it looks like it did manage to find it. If it doesn't, you may get an error that it wasn't able to build or it couldn't find it, and that's because you need to tell, sometimes when you first install it, you need to tell RCall where to look. If that happens, you can do this. You can set something called an environmental variable. And what it is R underscore home. You can't actually see the underscore here, but it's there, I promise. And then you want to set that equal to that path to the rlib directory that we talked about before. So that's in conda pkg pixie ends lib we go find the R library, we right-click that, we copy the path, and then we paste it in here. Oh, we need to put quotes around it though. Just tell Julia it's a string here. Oops. Come over here. Add some quotes. So we set our environment variable r_home to this. Once we do that, we can go back to our package REPL and say build RCall. And again, if it's already working, don't need to worry about this. This will just tell RCall to look into that rhome folder for the R libraries, and so it's going to sort of rebuild this package knowing where to look for the R executable. This may take a little bit of time. Okay, there we are. When we have this, now we can do a bunch of cool things using RCall. Okay, so we're going to use RCall, and one thing that we can do is we can just run our code using something called a string macro, where we put capital R and then quotes and then some R code. So for example, we might do 2 + 2. We did this last time, 2 + 2, and it's going to run that 2 + 2 in R, and it produces an output here. We can even assign variables into R. So let's say we wanted to know the output of that. Might want to take that that R code, and we might want to assign it to a variable. So I'm going to go back here, and I'm going to assign it to, say, the X variable. So we run that, and now I can get that variable X out of R into Julia using something called a macro. So rget X. And if we do that, now in Julia, X is assigned to the variable 4, which is the result of 2 + 2, which is pretty cool. Using this, we can also put variables from Julia. We're going to be doing that in a sec. We can put them into our R environment. But this is a really powerful package to do interoperability between R and Julia. To show you this, we're going to go back into our longitudinal analysis file, and we're going to start transitioning our R code into Julia code. So the first thing I'm going to do, I did RCall, I said using RCall here in the REPL, but we want to have this be reproducible inside of our notebook. So I'm going to go ahead and create a new Julia code cell now, where I'm going to say using RCall. And close that out. So we could run this cell. I've already run this code, so we don't have to worry about it. And now, for all of our R code, I can change this to Julia, and then I can wrap the code in our previous R cell in that R markdown string, or to this R string macro. And using triple quotes allows us to have a multi-line string. So I'm going to do R triple quote, wrap this in triple quote. You can see it maintains its syntax highlighting in R. And now if I run this cell, it's going to run it in Julia, but using RCall to load those packages in R. So I run this. You can see it's going to send it to the Julia REPL here, but it's going to run the R code and load those R packages. And then I can come down here, do the same thing. I'm going to change this to Julia. I'm going to say R, happily the same comment syntax in R and Julia. Wrap that in triple string, run that, and you can see now our sample files, or our sample object here and subjects object were created in R. Another really cool thing about RCall is that a lot of objects that we commonly use, things like tables, RCall automatically sort of knows how to make them into Julia objects. And to show you that, I'm going to grab the subjects variable here and the samples variable out of RCall, or out of the R compute environment into Julia. So again, we can use that macro rget samples. And when we do that, it actually comes in as a native Julia data frame. So data frames is the package that's commonly used for table kinds of operations. We're going to do more of that in the future. But here you can see now the samples variable is assigned to a Julia data frame with all of that same data. So this is incredibly powerful. And the reverse works too. If I create something with a Julia data frame and I say rput with that variable, it gets it into the R environment in the sort of native table that R can recognize. So this is very cool. Now, instead of going through and manually checking each of these individual code cells, I'm going to do a little bit of regular expressions black magic. If you don't know how this works, don't worry about it too much. I'll paste the actual code for this. But for regular expression aficionados, I'm going to show you how to sort of take every code block that we have and turn it into a Julia code block. So every Julia code or every R code block in this table starts with the triple backtick here. To pull up this, I should say, you can click this little search button here or do Control-Shift-F. And then we want to do open bracket and R, which matches the beginning. Now I want to take what comes after that R in any of these code cells, and I want to save it so I can replace that R with a Julia. So to do that, we're going to wrap this in a parentheses, and we're going to capture anything, which in regular expressions is dot, and then we do plus, and then we close that. We actually want to capture as little as we possibly can until we reach another closed bracket. Okay, so this finds why did that not work? One of the nice things about this sort of preview is that, oops. Oh, I know why. Because I need to tell it that we're using regular expressions here. Okay, so now we want R dot. We might have to do a backslash to escape that thing. R, and then we're going to open parentheses dot plus close parentheses close bracket with escape. So now we're capturing the first line. Now we're going to have a new line. Okay. Now we want to match basically any character that we can. The way to do this over multiple lines is, again, a little bit of a hack. I enjoy regular expression hacks, but we can do a /s, which is a space character, or a capital S, which is a non-space character. So basically anything. You can see we've just captured one of these. Then we want to do as many of these as we possibly can. Question mark does as few as you possibly can, but as long as it needs to be, to then match the other end of a code cell, which is, again, the three backticks here. Okay, so this is now capturing the whole code block. I should have said we want to wrap this guy in a parentheses so that we can capture that and replace it with a Julia code block of the same name. All right, so now we're going to go into replace. What do we want to replace it with? We want to do 3 backticks. We want to do open bracket. Now we want to do Julia. And now we want to replace, we want to take that first capture group, which, for example, here is going to be join data, and we want to include that. We do that with $1. And again, the nice thing about this is we can sort of build this up as we're going. So we get the inside of those brackets. We're going to close the bracket. We're going to do a new line. Then we're going to do the capital R, 3 quotes, and another new line, looking at what this is. So now we're building the beginning of that string. We're going to add the second capture group, which is all of that additional code inside of the box. Okay, and then we're going to do another new line. We're going to do another 3 quotes. We're going to do another new line, and then we're going to do 3 backticks. Okay, and when we click replace all, you will see magically we've now converted every code cell in the document with a Julia code cell of the exact same name wrapped in this string, this R macro string to actually run the code. And so to show you that that works, we were here before with the subjects and samples. We can run this cell. Oh, right, the cable stuff doesn't work because it doesn't have a browser, but if we delete the cable stuff, we can run the cell and we get the outputs, right? We can remove the cable stuff, remove that cable stuff, and we can run each of these cells throughout. So now we're at a point where we can run our code from Julia. We can pull our variables out of R into Julia and vice versa. I haven't shown it, but if we take Julia code, we can put it back into R. So this is a very powerful feature that we can use this package RCall to move code back and forth between different compute environments. And you can use this in all of your workflows. Down the line, let's say you adopt Julia, you really love it, and you find there's something, you're doing all of your code in Julia, but there's just some feature that you're missing, something that you know how to do in R, but you can't do in Julia yet. You can reach for RCall. You can run that exact same R code that you normally run. You can run it in the same compute environment, but you can get out the code that you need. So in the next video, we're going to start to transition this R code. We're going to start replacing some of these code blocks with Julia code that does the same thing. So we'll see you in the next one.